Hi guys. So today I am going to just go through that review similar to what we did last unit. That way in case you have any questions, you can kind of use this to reference how we're getting the answers that we are. All right, so the first thing that we did in this unit was special right triangles. So if you remember, there were two ratios. The first one was for a 45, 45, 90 triangle. So the ratio for 45, 45, 90 is x, x, and x times the square root of 2. So on this first one, it tells us that xy, side xy is 5. So what I'm going to do is I'm going to fill that in on my chart. 5 is across from the square root of 45. So I'm going to plug that in here, which tells me then that x is equal to 5. So if x equals 5, then I can plug in 5 here, and I also can plug in 5 for x here. So that tells me that across from 90 is 5 root 2. So side xz is 5 root 2. All right, looking at the next one. Again, we'll make this as a 45, 45, 90. So x, x, x times root 2. xz is 15. That's across from 90. So that goes in my chart in the 90 column. So x times the square root of 2 is equal to 90. I need to know what x is. So to solve for x, oh, I don't know why I wrote 90. Wow, that's 15. Sorry, guys. All right. So in order to solve for x, I'm going to divide both sides by the square root of 2. So I get that x is equal to 15 divided by root 2. Then if you remember, we have to get the square root out of the bottom. If you plug this into the Casio, it would do this next step for you, but I want to make sure you guys know how to do it. Multiply across the top, and I get 15 root 2. Multiply across the bottom, and I get just regular 2. So my x is 15 root 2 over 2. So that is across from 45, which is side YZ. All right. iPad's a little frozen. So on this next one, 45, 45, 90 again. Sorry guys, my iPad is not wanting to cooperate. All right, so YZ is the square root of 6. So we make our chart. X, x, x root 2 across from 45 is the square root of 6. That means that x is equal to the square root of 6. So everywhere there's an x, I plug in the square root of 6. The square root of 6 times the square root of 2 would be the square root of 12, but then we have to simplify the square root of 12. So remember 12, we can break down. There's a pair of 2's, so 2 goes on the outside and 3 stays on the inside. Again, if you were to plug root 6 times root 2 into the Casio, then that would give you that 2 root 3 as well. You'd still get that same answer. So across from 90 is 2 root 3. All right, so now moving on to 30, 60, 90. So 30, 60, 90 is x, x root 3, 2x. So let's fill in what we know. So AB is 10. 10 is across from 90, so that goes in the 90 column. That means that 2x is equal to 10. So if 2x equals 10, x is equal to 5. So then we're going to fill that in on our chart where there's an x. X is 5, so across from 30 is 5. X is 5, so across from 60 is 5 root 3. This wants us to find side BC, which is 5 root 3. All right, let's do 2 more 30, 60, 90s. So BC is 15. So 30, 60, 90, x, x root 3, 2x. So 15 is across from 60, so 15 goes in that column. So x root 3 equals 15. So to get x by itself, we're going to divide both sides by the square root of 3. And we have to get that square root out of the bottom. So the way I get the square root out of the bottom is I multiply the top and bottom by root 3. Again, if you plug that into the Casio, it'll do this part for you, but again, it's good to know. So this is 15 root 3 over 3, which then we can simplify that because 15 divided by 3 is just 5. So all that work to figure out that x is equal to 5 root 3. So x is 5 root 3. That's across from 30. That means that 90 is going to be 2 times x. So 2 times 5 root 3, which is 10 root 3. It wants AC, which is this one. All right, last special right triangle. So here's 30, 60, 90, x, x root 3, and 2x. AB is 2 square root of 15. So that is across from 90. So 2x is equal to 2 times root 15. So if I divide both sides by 2, x is the square root of 15. So I can fill in my chart now. X is the square root of 15. Across from 30 is the square root of 15. In the 60 column, I don't really have a lot of space, so I'll move that down here. I replace x with the square root of 15. I can multiply those together, and I get the square root of 45. But again, that actually can simplify. So the square root of 45, I can take 45. That breaks down into 9 and 5. There's a pair of 3's. So this is 3 square root 5. And that's the side, let's see here. Oh, it doesn't say which side to solve for, I apologize. Let's just go ahead and do a BC. All right, so that was 30, 60, 90, and 45, 45, 90 triangles. So the next thing that we did was a right triangle SOHCAHTOA trig. So remember your ratios. So we have sorry guys, the iPad is lagging. SOHCAHTOA. Sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. Tangent is opposite over adjacent. Then also remember, sine is the reciprocal of cosecant. Cosine is the reciprocal of regular secant. And tangent is the reciprocal of cotangent. So with cosecant, secant, and cotangent, we'll find the ratios, like we'll write the fractions. We won't use those reciprocals when we're solving though. All right, so let's find these 6 trig ratios. So in order to do that though, we need to find our missing side. So if you know 2 sides of the right triangle, you can use Pythagorean theorem to solve for the third side. So x squared plus 24 squared is 25 squared. So x squared plus 576 is equal to 625. Then we can go ahead and subtract 576. X squared is 49, square root, and I get that x is 7. So now I know my missing side. Now that I know my missing side, I can write all of those ratios. So we'll start with sine. Sine of theta is opposite over hypotenuse. So 24 over 25. Cosine of theta is adjacent over hypotenuse, 7 over 25. Tan theta is opposite over adjacent, so 24 over 7. Then we can do our reciprocals. So the reciprocal of sine is cosecant, so that's hypotenuse over opposite. The reciprocal of cosine is secant, that's hypotenuse over adjacent. Reciprocal of tangent is cotangent, so that's adjacent over opposite. All right, we also use trig to actually solve for values on a triangle. So we'll start by solving for sides. Okay, so what we need to do is write an equation. So on this first one, we have an angle, and then we need to look and see which 2 sides we have. So with 64, this is hypotenuse because it's across from the right angle. X is opposite. So we need to figure out which trig ratio uses opposite and hypotenuse, and that is sine. Then we write our equation, sine, and it's always sine and then an angle. So sine 64 equals opposite over hypotenuse. Then we need to solve our equation, so multiply both sides by 16. At this point, plug it into a calculator. Again, make sure your mode is in degrees, and I just realized my calculator is not. So then we plug it in, 16 times the sine of 64, and I get 14.38. All right, next one again, figure out which ratio to use and write your equation. So hypotenuse, and then for 21, that is the adjacent. So this is cosine. Cosine of the angle equals adjacent over hypotenuse. So for this one, I'm going to have to solve it a little bit different because the x is on the bottom of the fraction. If I multiply both sides by x, x still isn't by itself. I still have to divide. So what I'm going to plug into my calculator is 15 divided by cosine 21. And I end up with 16.07. All right, similar on the next one, we have to figure out which ratio to use. So I have 51 degrees. The x is across from 51, so that is my opposite. The 8 is next to it, that is my adjacent. I am not using the hypotenuse. I don't know what the hypotenuse is, and I'm not trying to find it. So this is tangent. So tan 51 equals x over 8. X is on the top, so multiply both sides by 8. Plug it into a calculator. And I get 9.8. We'll run that up, 9.88. All right, last one that's like this for the side. So again, I don't know or care about the hypotenuse. So this is opposite, this is adjacent, so this is tan. Tan 40 equals opposite over adjacent. X is on the bottom, so we're going to divide. So multiply both sides by x, divide by tan 40. So what you're going to plug into your calculator is 5 divided by the tangent of 40, which is 5.96. All right, we're also going to look at some word problems, or actually before we get to the word problems though, we also need to solve for angles. So remember, if you're solving for an angle, you need to use inverse. Okay, we use inverse to solve for an angle, but we still set up our equation. So we're solving for B. So here's angle B. This is hypotenuse, and compared to B, 12 is adjacent. So this is going to be cosine. So cosine of the angle. We don't know the angle, it's B. And then it's adjacent over hypotenuse. Now the way we actually solve this on the calculator is we use inverse. That's the thing with a little -1. So second cosine or shift cosine on your calculator. So shift cosine, and I end up with 45 degrees. Well, 45.1 degrees. It's not exactly a 45, 90, but it's pretty close. All right, then looking at the next one, we want angle A this time. I have adjacent and opposite. So tan of the angle, tan A, equals opposite over adjacent. So we can write this as tan inverse. Again, when you're looking for an angle, you have to use inverse. Shift tan 8 over 10. And I get 38.7 degrees. So now we'll look at the word problems. So with the word problems, it's all about just getting your picture. We're going to have to draw a right triangle somewhere. So keep that in mind. There will be a right triangle. So the Leaning Tower of Pisa makes a 10-degree angle with the ground. The actual tower is 60 meters long. So here is my Leaning Tower. All right, here is the ground. It makes a 10-degree angle with the ground. So this is my 10 degrees. We're trying to find the height, which will be where your right angle is. And it says the actual tower is 60. So this is 60 and this is x. Once your picture is drawn, this is hypotenuse, this is opposite. So we're going to use sine. So sine 10 is x over 60. Multiply both sides. Plug in 60 sine 10. And I end up with 10.42. Now, I do realize now, when I made this question, I used a very inaccurate measure. I apologize, guys. When I looked it up real quick, I just wrote the angle down. So the reality is that angle is actually a much larger number. I wrote that down incorrectly. But this is how you solve the problem based on the points that you are given. So for this next one, you have a 6-foot tall person. So here's my person. They have a 5-foot long shadow. So the shadow's on the ground, unless you're Peter Pan. And then that makes our right triangle. So usually when you see this question, it tells you the angle of elevation. Now, that's usually the terminology you'll see. We didn't talk a lot about angle of elevation. I didn't want to confuse you guys. But I want to make sure you talk about, we're talking about the angle on the ground. So we are looking for this angle. That's right here. Okay, so yes, there's a right angle there at the ground, but the angle we're looking for is the one that's not the right angle. Okay, so if this is 6 and this is 5, then we can use tangent. So tangent of our angle equals opposite over adjacent. To find an angle, we use inverse. Then you can plug that into a calculator. And you get 50.19 degrees. All right, so then the last trig ones we did were the ones where you have to draw a triangle. So it tells you cosine theta is equal to 3 over 5. It doesn't tell you what theta is. We don't actually need to know what theta is. We just need to draw a triangle and fill it in. So we'll put theta on there. Cosine is adjacent over hypotenuse. So adjacent is 3, hypotenuse is 5. To find that missing side, we can do Pythagorean theorem, which this is a triple, so that's 4. Now I just need to find cosecant based off this triangle. Cosecant is hypotenuse over opposite. Theta, based off that theta, hypotenuse and opposite, it's 5 over 4. All right, cotangent of theta. Again, we're going to draw a triangle. We're going to fill it in. Cotan, reciprocal of tangent. It's adjacent over opposite. So adjacent is 8. Opposite is 15. We can use Pythagorean theorem here to find our missing side. This is also, though, one of your triples, and this should be 17. All right, sine is opposite over hypotenuse, which is 15 over 17 on the triangle that I drew. So label your two sides, use Pythagorean theorem to find your missing side, and then write your new ratio. All right, so after trig, then we came back from Thanksgiving break and we started looking at all these degree measurements. So we started off a little bit easier with degrees before moving into radians. So the way we sketch these angles, we figure out which quadrant does it end in. So I'm going to go ahead and label the ones that we know. I've got 0, 90, 180, 270, 360. So 472, that's more than a full circle. So what we would do first is we would find that coterminal angle, and then we'll figure out where 112 goes. Well, 112 is in between 90 and 180. But to draw that arrow, remember, we're not graphing 112, we're graphing 472. So I'm going to do a full circle and then end at that side. All right, negative angles, if we're going in the opposite direction, we're going to go backwards. So if I'm going to negative 234, I'm going to end in between negative 180 and negative 270. And then negative 515, again, that's more than a full circle. So let's go ahead and add 360. Let's go ahead and get that coterminal angle. And then we're going to figure out which quadrant that goes in. So again, going backwards, 0, negative 90, negative 180. So negative 155 would be here. I did a full extra circle, though, and I'm going to show that with my line. And there's my angle. All right, what we just did was we found coterminal angles. Just remember, there are an infinite number of coterminal angles, so you can find a whole lot of them. You can add or you can subtract 360 a whole lot of times. So one coterminal angle would be to add 360, and I get 395. I can take that and I can add 360 again. I can add 360 again. Or I could have subtracted 360 from the very start. If I took 35 and I subtracted 360, then I could get another coterminal angle. So 35 minus 360 would be a negative 325. I could subtract 360 again. And again, I can keep doing this to get any number of coterminal angles. So all of those are possible coterminal angles. So same thing with negative 112. I could add or subtract 360. If I add 360, I get 248. I can add 360 again, and I get 608. I could add 360 again, and again, you can just keep adding it over and over and over. Or you could have taken it, and you could have subtracted 360. So negative 112 minus 360 would give us negative 472. Subtract it again. And you can keep going as long as you need to. Again, pick any three of those. Those are all coterminal. So coterminal angles, they end in the same place, add or subtract a full circle. All right, and then we looked at reference angles. So remember, reference angle was the distance between the ending side and the x-axis. So 335, let's start by figuring out which quadrant it's going to go in. All right, so 335, if this is 360 and this is 270, 335 will be in this quadrant. The reference angle is the distance in between here. So if this is 335, then the distance between those two angles is 25 degrees, and that's my reference angle. All right, to do 510, again, we're going to need to find a coterminal angle that's more than a full circle. So let's subtract 360. So let's figure out where 150 is. 150 goes in quadrant 2. Reference angle is the distance in between those, which is a distance of 30 degrees. All right, so the next two is when we kind of started combining the trig a little bit. This is a little bit more trig and a little bit less degrees. So remember, these are kind of the hard ones to draw the picture for. So what we're going to do is we're going to start by plotting that point. So I'm going to go to 8, negative 15. And I'm going to make that point there. I'm going to draw a line that goes to that point. That's the angle. And then I'm going to connect it to the x-axis. Connect it to the x-axis. And that makes your right triangle. Then we also draw a theta on the x-axis. All right. Then we label our points. And remember, this time we can include potential negative values. So I went to the right 8, but I went down 15. Because I went down 15, I'm going to label it as a negative. Now, our hypotenuse will always be positive. All right, but let's go ahead and find our hypotenuse using Pythagorean theorem. Remember, when you square the negative 15, the negative 15 should be in parentheses, and then the squared is outside the parentheses. So if I work this out, I'll get 17 as a hypotenuse. That's actually one of your triples, if you don't remember. And now once our triangle's filled in, we just find our 6 trig functions. So opposite over hypotenuse, adjacent over hypotenuse, opposite over adjacent. Cosecant is the reciprocal of sine. Secant is the reciprocal of cosine. Cotangent is the reciprocal of tangent. So last one like this, we'll go ahead and plot negative 3, 4. We're going to plot our point, connect it to the x-axis to get our triangle. Theta goes next to the x-axis. I went left 3, so the negative is down there this time. I went up 4. Pythagorean theorem, this is one of your triples. Your hypotenuse is 5. And then we just find our values. So sine is opposite over hypotenuse. Adjacent over hypotenuse. Opposite over adjacent. probably going to be another bell in about 5 minutes. Sorry, guys. It's lunchtime. Opposite, hypotenuse over opposite. Hypotenuse over adjacent. And adjacent over opposite. And those are your trig values. All right, then the last thing we did was probably the hardest. That was our radian values. So lots of fractions with the radian values. So to sketch the angle, it's really helpful to write pi and 2 pi with the same denominator. So the first one on here is 11 pi over 8. So I'm going to go ahead and write, here's 0, here's 1 pi. I'm going to write 1 pi with the same denominator. So that denominator is 8, so 1 pi is 8 pi over 8. I'm going to write 2 pi with the same denominator. So 2 pi, if I multiply the top and bottom by 8, gives me 16 pi over 8. All right, so if I start at 0, I'm going to go to 11 pi over 8. 11 pi over 8 is more than 8. It's closer to 8 than it is to 16. 16 would be 5 away, 8 is only 3 away. So 11 pi over 8 is going to fall in quadrant 3. All right, negative angle. So again, if you want to find a coterminal angle and look at it positive, you can do that. Or you can move in the negative direction, whichever way is easier. But here's 0. 1 pi with the same denominator is 4 pi over 4. 2 pi with the same denominator is 8 pi over 4. So if I'm going to go backwards, then I'm going to go 0, negative 4 pi over 4, negative. So we're going to move this way. So negative 7 pi over 4, I'm going to go past 4 pi. I'm going to be closer to negative 8 than I am to 4. So that is negative 7 pi over 4. All right, 8 pi over 3. Again, let's write 1 pi and 2 pi. 1 pi with the same denominator is 3 pi over 3. 2 pi with the same denominator is 6 pi over 3. Well, 8 pi over 3 is more than 6 pi over 3, so we need to find a coterminal angle. I need to subtract 6 pi over 3. So 2 pi over 3, let's figure out where that goes. 2 pi over 3 is not quite at 3 pi over 3, so it's going to be somewhere in those two. 2 pi over 3 is closer to 3 than it is to 0. To draw my arrow, though, I found a coterminal angle, so I had to show that I did that full circle before I got to that point. All right, again, finding coterminal angles, we're going to add or subtract 2 pi. Again, if you are really struggling with this, you could do this on the Casio. You could plug that in and actually put plus 2 pi without getting that common denominator and actually still find your answer. But again, like I said, it's really helpful to know how to do it without a calculator if you're going into calculus. So in order to add that, we need a common denominator. Right now, it's 2 pi over 1. I need a denominator of 5. So I'm going to multiply the top and bottom by 5. Then I can add across the top, and I get 11 pi over 5. Remember, though, there's an infinite number of answers here. I can take 11 pi over 5, and I can add 2 pi again. I can take that answer, and I can add 2 pi again. And I can keep adding 2 pi as many times as I want to keep finding coterminal angles. I also could subtract 2 pi. So I could take the original minus 10 pi over 5. And then again, I can do it multiple times. I can keep subtracting or adding 2 pi as many times as I want to. Any of these are coterminal angles. All right, on this next one again, you can add 2 pi, but you have to get a common denominator. 2 pi is 8 pi over 4. Add across the top. There's your first coterminal angle. You can add 8 pi over 4 as many times as you want to get multiple coterminal angles. So keep adding or subtracting it in order to get more coterminal angles. Sorry guys, that That should be the last bell for the video. All right, converting between the two. So to go from degrees to radians, we multiply by pi over 180. That's because if you start with degrees, you don't have a pi, and you usually will have a pi in your radian value. So you want to end up with a pi on the top when you're going to radians. So 25 over 1 times pi over 180. So this would be 25 pi over 180. And then simplify your fraction. Those are both divisible by 5. And I think that's 36. That should be 36. All right, 12 over 1 times pi over 180. Those are both divisible by 12, I believe. I know it's divisible by 6, so it should be 15, I believe. Let me double check myself. Pretty sure it's 15. Yeah, 15. So I get pi over 15. Going from radians to degrees, we go the opposite way. We want to have, we're going to get rid of the pi's. We want the pi's to cancel out, so we do 180 over pi. I'm going to go ahead and simplify before I multiply to make it a little easier. Diagonally, the 6 and the 180 are both divisible by 6. So I'll make that 1 and make that 30. So that's just 5 times 30, which is 150 degrees. All right, negative pi over 12 times 180 over pi. The pi's cancel. I'm left with just a negative 180 over 12, which I can go ahead and do and simplify for a negative 15 degrees. All right, so the last thing we're going to do is we're going to find reference angles in radians. So we have to start by figuring out which quadrant does this go in. So let's figure out where 3 pi over 5 is going to go. So again, I'm going to go ahead and write 0, 1 pi with the same denominator. The denominator right now is 5, so 5 pi over 5. 2 pi, 10 pi over 5. So let's figure out where 3 pi over 5 is going to go. So 3 pi over 5 is less than 5, and it's closer to 5 than it is to 0, so it's going to be over here. The reference angle is the distance between the x-axis. So if I look at that total distance, it's 5 pi over 5 minus 3 pi over 5. So my reference angle is 2 pi over 5. All right, 17 pi over 12. Let's figure out which quadrant it's in. 0, 12 pi over 12, 24 pi over 12. 17 pi over 12 is more than 12. We need to figure out, is it closer to 12 or closer to 24? So it's 5 away from 12, and it is 7 away from 24. So we are closer to 12. So there's 17 pi over 12. Reference angle is the distance in between the x-axis. So 17 pi over 12 minus 12 pi over 12 gives us 5 pi over 12. All right, negative pi over 3, so 0, 3 pi over 3, 6 pi over 3. If I'm going negative, I'm going this direction. So negative pi over 3, I'm not going to reach negative 3 pi over 3. It's going to be closer to 0 than it is to 3 pi over 3. So we're in the fourth quadrant. Reference angle is the distance to the x-axis. I went pi over 3 away, so my reference angle is pi over 3. Remember, reference angles are always positive. Reference angles are always positive. All right, and then last one, in order to figure out which quadrant it goes in, we're going to need to find a coterminal angle. But if you don't know that, let's go ahead and label 0, 6 pi over 6, 12 pi over 6. So 12 pi over 6, again, 13 pi over 6 is more than that. So let's go ahead and subtract 12 pi over 6. Subtract a full circle, find a coterminal angle. Pi over 6 does not get to 6 pi over 6. It's closer to 0 than it is to 6. Reference angle is the distance in between, which is a distance of pi over 6. All right, so that is your review for your test.